Find the slope of the tangent line to the graph at this arbitrary point, C, f of c. We know the y-coordinate would be f of c if the x-coordinate is c. So it's the same amount of work, maybe a little bit more, because there's some numbers that we had before that kind of all got together and canceled. And here we'll have some values that, well, we hope everything except the delta x or the factor of delta x in the numerator will cancel. This is the limit as delta x approaches 0 of f of no specific value for c, so we'll just say c plus delta x minus f of c all over delta x. We have the specific function, 3x squared minus 8x. So we can evaluate this function at c plus delta x. We take 3, and we substitute in c plus delta x, and we square it. Minus 8 times the c plus delta x. And here I don't have the option. Well, I guess I could find f of c off in the margin, but really it's just a matter of substituting c for x. So the main thing to remember, we've got to put the two terms there. Make sure they're enclosed in parentheses. So it's going to be 3c squared minus 8c. F of c is what we get when we substitute c for x. All over delta x. We're still moving forward on the hope that when we clear all the parentheses and combine like terms in the numerator, delta x will be a factor of the numerator so that we can factor it out.
And where did the 3c squared minus 8c come from?
Well, it's directly from here.
Okay.
And finding f of c. F of c, like f of 2, substitute 2 for x. It's just the rules for evaluating functions. F of c, we substitute c for x. When we define derivative in the not too distant future, f prime of x, we'll just leave it an x rather than choosing some different letter of the alphabet, because we want the derivative to be a function of x, just like the original function is a function of x. But for now, we're calling it c. So the specific value is just yet to be announced. So the tough algebra, c squared plus, it's going to be the product, c times delta x times 2, so 2c delta x plus what we get when we square the delta x, minus 8c, minus 8 delta x, minus 3c squared plus 8c. Distributing that minus across the parentheses. The potential for some cancellation, actually some actual cancellation, the minus 8c and the plus 8c. We can go ahead and cancel those. That's good. Distribute the 3 across the parentheses. At the next step, the limit as delta x approaches 0 of 3c squared plus 6c delta x plus 3 times delta x squared minus 8 delta x minus 3c squared all over delta x. What else cancels? Yes, 3c squared and minus 3c squared will cancel. And that's good news, because every remaining factor in the numerator, every remaining term in the numerator has a factor of delta x. So we're going to be able to factor it out. And I think probably now is the time, because technically no two of those 3 terms are like terms. So let's go ahead and factor the delta x out of the numerator. This equals the limit as delta x approaches 0 of delta x times 6c plus 3 delta x minus 8 all over delta x. So we divide the 6c delta x by delta x, divide 3 delta x quantity squared by delta x, divide 8 delta x by delta x, and we have the expression, the trinomial in the parentheses. Divide out the delta x's. So limit as delta x approaches 0 of 6c plus 3 delta x minus 8 and finally, I suppose it would be clear that the minus 8 and the 3 delta x are associated with this. It certainly is clear from the context. We know we want to find the limit of that entire expression. I suppose if somebody just walked in and was trying to follow this, maybe they could think the minus 8 is off to the side. It really doesn't matter, just so long as the delta x is in there. But just the limit of that entire quantity. And the limit of that entire quantity, when we substitute when we substitute 0 for delta x, no more limit, it's going to be 6c plus 3 times 0 minus 8, or 6c minus 8. 3 times 0 is 0, and it makes a contribution of 0 to that expression. So having found this expression, what's the first thing we should immediately do to convince ourselves that there's validity to this expression based on what we've just done? Does it work if c equals 2? Right? We should ask ourselves, does it work if c equals 2? If c equals 2, what is the value of 6c minus 8? It's 4. So sure enough, previous example, if c equals 2, we get 4. But now, it's easier to ask the question, well, what if c equals 3? 6 times 3 is 18. 18 minus 8 is 10. So the slope of the tangent line would be 10 in that case. So we can go back to the graph. If at 3, whatever point there is on the graph with an x coordinate 3, second calc value, plug in the 3. So the point 3, 3, evidently the slope is 10. Now again, don't try to get that with a visual because of the tiny distance comparatively between tick marks on the y-axis. But if we were to find the slope of the tangent, the equation of the tangent line, let's see, just considering this, y minus 3 equals 10 times x minus 3. Y minus 3 equals 10x minus 30. Y equals 10x minus 27, I want to say.
That's 33.
Is it 33?
No.
Oh. So it would be 10x minus 27. So graph okay, so we have the slope of the equation of the tangent line to the graph at the point 3, 3. Didn't ask us for that. That was a little something extra there. But the expression 6c minus 8 looks like it's working for us. It looks like pick a c, any c in the domain of this function, substitute that number for c, and it will give us the slope of the graph.